Okay, so continuing our little journey on logs, we're now going to talk about the three rules of logs. So we know about the definition of logs, so what a log is, that we can convert between index form and log form. So if log base A of C equals B, then A to the power of B equals C, and vice versa. So being able to convert between the two notations is really important. Okay, so then we come on to the three basic rules of logs. Now these are going to be applied in lots of different contexts, but the basics needs to be nailed down, and it's often it's often best to kind of think that logs can be quite easy because it will always boil down, or nearly always boil down, to something to do with these three rules, because that's why we use them. So if we have log to a base of a number, and we have log to a base of another number, and we add those two logs together, the answer to it will be the log to that base of the two numbers multiplied together. Similarly, if I have log to a base of a number, and I have log to the base of another number, and I subtract one from the other, I end up with log to that base of the first number divided by the second number. And then the third rule is if I have log to a base of a number which is taken to a certain power, then that is equal to that power multiplied by log to the base of the number. And we often think about that, and you'll hear it a lot, teachers saying it and students saying it, that we just drop the index down. So this number has come down to the front and multiplied. Okay, so they have got to be learned, remembered, become second nature. Nothing more to learn than those three and the definition. Everything else is about application. Okay, so let's apply those to some problems. Nice and simple ones to start off with, I think. So I have the first one. If you want to pause the video, by the way, and have a go at this, then by all means do. I'll just run through them. So I've got log to a base of 6. I've got log to base 3 of 6. I've got log to base 3 of 7. So those two bases are the same. So I can bring those two together by my first rule of logs. Remembering, if I add two logs together with the same base, I can multiply the numbers and it becomes a log of that to that base. Okay, so nice and straightforward. So that becomes log to base 3 of 42. Okay, the next one, I've got log to a base. Doesn't matter what the base is, as long as these two are the same. And this time it's a subtract. So I can use my second law, log to a base of a number minus log to the base of a number. So I do the divide and bring them into the same log, bring them into a single log. So I end up with log base 2 of 15 divided by 3, which equals log base 2 of 5. Okay. Okay, so let's look at the third one. So I'm adding two logs together there, but actually I've got two lots of the first one, so the bases are the same. Now a common mistake here would be to write that as as 2 log 5 base 5 of 6. Sorry, excuse me. Would be to write that, to bring those two together. However, we can't, because the 2 is only applying to the log base 5 of the 3, so that would not be correct. So what we need to do is to apply two separate rules on this one. So that first of all, we need to bring that just into a log. So remember in our third rule, which says that these can go this way as well. So I've got a number multiplied by a log, and I can bring that up to there. So I can write my first 2 log base 5 of 3 as log base 5 of 3 squared plus log base 5 of 2. So now I have log base 5 of something plus log base 5 of something, and I'm into the form where I can use my first rule of logs. So I end up with log base 5, that's 9, isn't it, of 9 multiplied by 2. So that becomes log base 5 of 18. Okay. Right, let's carry on with some examples. So what I'm going to do this time, I'm just going to sort of go use the same rules the other way. And what I want to do here is to write these logs in terms of log of x, log of y, and log of z. So I'm going to separate it, and that's often going to be something you'll be doing. Okay, so freeze it and have a go, and I shall proceed. Okay, so again, common error would be to bring the 3 down. Bring the 3 down there, or bring the 2 down, or get some sort of muddle there. But we can't do that because that cube there is only applying to the z. That square there is only applying to the x. So I need to use my first rule, the multiplication one, to separate these into 3 separate logs. And then let's see where we go from there. So I've got log base a of x squared plus log base a of y plus log base a of z cubed. Okay, and now I can apply my third rule to bring my indexes down. Okay, so I've got 2 log a log base a of x plus log base a of y plus 3 log base a of z, and that not written out very clearly, and that is the answer to that. Okay, let's do the next one. So a similar idea, but this time I've got log base a of something divided by something, so I'm going to write that as x minus log base a y cubed, because I've got that divided by that, so it separates into 2 logs, and one subtracted from the other. Here I've got a 3 up here, so I'm going to use my third rule on that one, so that becomes log base a x minus 3 log base a of y, and that is that written as in terms of log of x and log of y. Okay, so that's really important to get those sorts of basics nailed. Being able to simplify logarithmic expressions is something that's going to apply to other types of question, particularly in solving exponential equations. So the next video will be how we start using this now. But first job is to get really comfortable with those 3 rules and the definition and being able to apply it to certain expressions. So use the practice questions as best you can on that. Make sure you're nice and solid. Okay, hope that was helpful. Bye.